So let's talk about domain and range of negative 2x plus 5. So it's a linear function. If we're looking at the graph, I think the easiest way to figure out domain is you want to ask yourself, does this graph have any starting or stopping points as I move from left to right? Does it just appear out of nowhere? Does it stop and not continue? Or is this one completely continuous? Now, there's not any arrows on your graph there, but technically there should be. On the ends of that line, you should put some arrows because I've just selected a small viewing window here for us to look at. I could zoom out of this and you could observe that the graph continues. It doesn't matter how far you zoom out, it's going to continue in all directions. So the domain here is all real numbers. So we have a symbol for that. If you've forgotten about that, the symbol, it looks like a T and an R put together, or an R with an extra back on it, however you want to look at it. That's the symbol. Something that is new in Math 3, it's not new in Math 3, but new to you is what we call interval notation. Here's how we also want to represent that. It looks like a point. You put it in parentheses, but we're going to write negative infinity, comma, positive infinity. What that means is any number between the biggest negative number that you could possibly imagine, between that and the biggest positive number that you could possibly imagine, any number between those works. If you plug it into the function, you're going to get an answer. You can multiply any number that you want to by negative 2, you're going to get a result. You can add 5 to it, you're always going to get a number. There aren't any issues, there aren't any problems. Okay, range, and let me write this right here, left to right. Just to remind you, if you're looking at the graph, what are you looking for? Okay, left to right on the domain. Range, we're looking bottom to top. Okay, range, we're looking bottom to top. So same thing here. We're looking for, are there any starting points, any stopping points, any breaks in the graph? Are there any issues? Well, if I look here at the bottom, this arrow tells me that it keeps going down to the bottom. So it doesn't have a starting point here. If I look up at the top, I've got another arrow. That means it keeps going. It's never going to stop. So this one also has a range that's exactly the same as the domain. All real numbers, negative infinity to positive infinity. Okay, the y-intercept. We can observe the y-intercept very easily. Right? We're looking at the y-axis where it crosses the y-axis. Let's express that as a point, though. From 0, 5 is the point. The x-coordinate is 0. The y-coordinate is 5. Our x-intercept is where we cross the x-axis. So we can observe that on the graph as well. It's between 2 and 3. Usually, I don't like for you to guesstimate what it is. I like for you to find it exactly. But in this case, it is safe to say that is exactly between 2 and 3. It's 2.5, and the y-coordinate is 0. Okay, increasing / decreasing. Which one is it doing? Is it doing a combination of both? I'm going to write another reminder right here that I always look from the left side of my graph to the right side of my graph. And as we're looking at this linear function here from left to right, it's always moving downward. So this is decreasing. And we want to say where it's decreasing. Well, it's decreasing everywhere. So from negative infinity to positive infinity, this function is decreasing. Never increases. Okay, rate of change. We mentioned that earlier. It's the rise over the run. It's the slope. We're looking at the equation. We're looking at the graph. There's several different ways that we can identify the slope. From the equations, the easiest, right? This is the slope, the number right in front of your x. So the rate of change here is -2. I can also look at my graph. I start at, let's just start at the y-intercept and go to another point on the graph. We go down 2 and right 1. So there is another way to observe the rate of change of -2. Okay, extrema. Remember I told you that was just the combination of all maximums and all minimums. So is there a highest point to our graph, or is there a lowest point to our graph? No, we don't have either of those because it continues increasing, it continues decreasing. There's no highest point that we reach, there's no lowest point that we reach. It just keeps going in both directions. So this one has no extrema. All right, last thing here, in behavior. This is how in behavior is expressed. Okay, this part should always be given to you as x. That arrow means approaches. Okay, so since it's the first time we've seen it, let's write it out. That arrow means approaches. Negative infinity, well, negative x values, those are on the left. Okay, so as x approaches the left, where's our graph going? Our graph is going up, so the y values are going to positive infinity. Positive infinity translates to it's going up. Okay, as x approaches, again, the arrow means approaches. Positive infinity, well, positive x values are on the right. Positive x values are on the right. Look at the right side of your graph. The right side of my graph is going down, so the y values are going to negative infinity. Okay. So technically the words aren't part of the answer. The answer really, all they're looking for is the positive infinity and the negative infinity. But I think it's helpful to attach the words to it so you know what those symbols mean. Because they can be intimidating. I understand that completely.